Hello students, welcome to Subsys classes. Today we will be solving the NBHM PhD scholarship exam questions which came in the January 2018 paper. We will be solving the section 1, which is the algebra portion of the paper. We will be solving this 7th question today. The question is that if A, the matrix A, belongs to M5C such that A square minus A square minus I whole square is equal to 0, and if it is assumed that A is not a diagonal matrix, then which of the following statements are true? Option A is diagonalizable. Option B, A is not diagonalizable. Option C, no conclusion can be drawn about the diagonalizability of A. So we have been said that A belongs to M5C such that A square minus I whole square is equal to 0. It has also been told that A is not a diagonal matrix. Then we need to find out whether A is diagonalizable, or if A is not diagonalizable, or if no conclusion can be drawn about the diagonalizability of A. So let us start off. We've been said that A square minus I whole square is equal to 0. So therefore the characteristic polynomial will be of the form, this A square minus I whole square can be written down as, basically we can write x square minus 1 whole square, and this will be equal to x plus 1 into x minus 1 whole square, and this will be equal to x plus 1 whole square into x minus 1 whole square. So this is basically the characteristic polynomial. So if A is diagonalizable, then minimal polynomial of A is x plus 1 into x minus 1, and this is a product of distinct factors. Now, products of distinct factors of what? Distinct factors of the characteristic polynomial. Okay, so if A is diagonalizable, then minimal polynomial is of this format. Now, why I have written that minimal polynomial is of this format and not any other format? Because one thing that I forgot to mention after this statement is that the minimal polynomial which will exist, the minimum polynomial will always divide the characteristic equation, or we can write that minimum polynomial in this case will divide x plus 1 whole square into x minus 1 whole square. This is the statement, and after this statement we are coming back to this step. So this is the thing. So if for A is diagonalizable, minimal polynomial of A will be of this format. Now if A is not diagonalizable, if A is not diagonalizable, then minimal polynomial will be of the following formats. Then minimal polynomial will be of the following formats. Let us talk about those formats. So the first format will be either it will be x plus 1 whole square into x minus 1. This is one format, and there can be another format where it is like x plus 1 into x minus of 1 whole square, or third format can be x plus 1 whole square into x minus of 1 whole square. So these are the three formats for which A is not diagonalizable. Okay, so these are the formats. So therefore we can say that we cannot be totally sure about A being diagonalizable or non-diagonalizable based on these formats. So therefore, since the there is no conclusive evidence of the form of the minimal polynomial in the given question, so therefore we cannot say anything about the diagonalizability of A. So therefore no conclusion can be drawn about the diagonalizability, let me move it upwards, about a diagonalizability of the matrix A. Okay, so therefore option C is the correct option. So today we have solved a question which came in the NBHM 2018 paper. We will be solving many such questions in the subsequent videos. Till then, keep watching Software Classes videos for more solutions and content. Thank you very much.